Now, last but not least, after this, we will have 7 innovators come to the stage to share how they will try to tackle the challenges that we are discussing today. So while they sit at very different part of the supply chain and at a different stage, they are all backed by energy CVCs. So the list here you see today are based on the nomination, screening, and also selection by the council members. So again, my final comment before we have them on the stage. So there will not be Q&A sessions due to the time constraints. So if you are interested in learning more about any of those companies, you're more than welcome to reach out to them directly, or feel free to reach out to the GCV team or the Energy Council, and we'd be happy to facilitate input. So with that, I'll let Fernando to take the stage.
All right, thank you, Tony. And just chiming back in, just to introduce the 7 startups that will be presenting today. So in order, they will be AIS Field, Ardent, Einstead, Electrified Thermal Solutions, Miraco, Thea Energy, and Waze. And to kick off the proceedings, we have Kayahan Gundodu from AIS Field. The floor is yours.
Yeah, hello everyone. Let me quickly share my screen. Hello everyone, I am Kayahan from AIS Field, and I am one of the founding partners. And let me quickly start by giving you a brief overview of our company and what we do. At AIS Field, we combine over 60+ years of experience to provide robotic inspection solutions, and we are doing this for challenging field conditions, hence where our name comes from. Our mission is to transform how inspections are performed in the industry by leveraging digital technologies such as robotics and AI. So the core problem we focus on is related to hydrocarbon storage tanks, as seen in the above picture. In oil storage facilities, conventional maintenance requires taking tanks out of service for several months. This downtime results in significant opportunity cost, as the product cannot be sold during the maintenance. This results in a cost of approximately $2 million. And beyond the financial impact, the conventional approaches involves confined space human entry, as you can see in the pictures below, and generates excessive environmental waste, raising serious HSE concerns. And we address this problem with our Oil Diver technology. The Oil Diver robotic system is designed to be submerged in oil tanks while they are filled with liquid. This ATEX certified explosive-proof system performs detailed inspections in accordance with international standards. Developed in collaboration with Turkish petroleum refineries, Tüpraş, and successfully deployed in over 10 tanks, our patent-pending system provides significant value. And we are always striving to increase the value we create. As a research and development company, we are working to expand our Oil Diver robots applications to different products, such as crude oil, to smaller assets where access is much more restricted, and various asset geometries, such as internal floating roof tanks. Our major goal is to triple the market size of Oil Diver with these new offerings. So in addition to our Oil Diver robot, we have numerous maintenance and inspection robotic systems and softwares, all addressing specific problems in the industry. All of these systems share a similar vision, reducing the human involvement and ensuring smarter, faster, and safer processes. To be more analytical about our approach, with a single tank inspection, online tank inspection, we facilitate significant reduction in times and costs. Additionally, we eliminate 1,500 hours of confined space labor. In addition, environmental waste and CO2 emissions are also eliminated. None of this impact will be possible without the team behind AIS Field. Let's take a quick moment to introduce you to the team. We are 4 individuals as founders, and each of us is responsible for different aspects of our operations. As you can see, our team is highly experienced, and therefore we can understand the challenges in the field. If we take a closer look at the market landscape, there are over 100,000 storage tanks worldwide. And considering geographical distribution and the applicability of our technologies, a good portion of them is within our reach. Inspection robotics is growing rapidly due to 2 main reasons. First is updated, more stringent environmental regulations, and secondly, rigorous inspection standards caused by that. On top of these, digitalization reduces costs and improves safety. If we have a brief look at our competition, Considering our robots capabilities, our site experience, and our 15 years of NDT data fueling our AI developments, we believe we can capture significant market share despite the competition. Along with our supplementary inspection knowledge, strengthens our position further. So in this market and competition, our business model is robotics as a service. We conduct business through long-term framework agreements with large asset owners. Our long-term vision is to expand our application area to all industrial assets. As our pre-seed investor and also customer, Tüpraş has noted, becoming greener is a crucial trend in the oil and gas and power sectors, and we help our customers do exactly that. To capitalize on all the opportunities mentioned above and accelerate our growth, we are seeking strategic partnerships and also financial backing. We are seeking an investment of $1.5 million for establishing a strong commercial team, strong infrastructure, and improving our systems. As a startup that recently completed all the major pilots, this investment will accelerate our international expansion and help us capture a significant market share before the competition intensifies. Thank you very much for listening and for your time.
Thank you, Kayhan. Next, we have Christine Parrish from Ardent.
Hello, nice to meet you all today. I'm Christine Parrish with Ardent, and we're going to talk today about near-term practical decarbonization with the universal adapter that are membranes. Heavy industry is the largest source of CO2 emissions without a clear path to decarbonization. Transportation has electrification, power has renewables such as solar, wind, and hydro, but heavy industry needs to be decarbonized too. If we look at the amount of CO2, it's 600 gigatons that will be emitted by 2070 from existing assets that are in the ground today and are unlikely to be decommissioned, so therefore need to be decarbonized. And point source carbon capture is one of the most practical options to meet these decarbonization goals. And when we think about carbon capture, separation is the biggest cost piece of that puzzle. Transportation, storage are well known and fixed incompressible costs. So the Ardent team thinks about major cost savings for the carbon capture piece of the puzzle because the membranes provide a technology unlock because they like hot, wet, low concentration CO2 at low pressure, which starts to sound a whole lot like point source carbon capture. And it's a nice marriage of a technology fit and the stream of which we're tackling, which allows us to shrink the plant cost. The chemical compatibility of our membranes means we can also shrink pretreatment and come up with a low energy, simple balance of plant solutions to help us beat incumbents in the market and also address the underserved flue gas streams now that are too small for technology that requires economy of scale. And Ardent is doing this and unlocking near-term carbon capture and storage by improving our cost. So I said simplified balance of plant, and that's really reducing the steel that's needed, but also the membranes being as efficient as possible and shrinking the footprint of the plant. Ease of use. These are non-amine-based technologies that are a continuous process that don't require regeneration or waste handling and can be operated by people in plants today. And membranes are also a universal adapter. So they provide flexibility to go to 60 or 70% CO2 for lots of utilization applications, but they also work well with incumbents to allow them to address lower concentration CO2 sources with the membranes acting as that bulk separator in front. And here you can see the membranes are a totally electrified solution. So the largest effect on the cost of capture is going to be your cost of electricity. You can see in the near term with what we have validated in the field today, we're looking at a lot of applications under $100 a ton for all-in cost of capture. These include both capital and operational costs on the left hand to go to sequestration, on the right hand to go to utilization. And Ardent is really filling the gap that we have heard from our customers in the landscape. This is a validated technology platform. We have membranes at a commercial demonstration now in olefin paraffin separations. where we've done a lot of the engineering work to understand what the system looks like, which allows us to design this modular, low-cost system. And in some cases, we can actually use the same manufacturing lines that we're using for our existing technology now to allow us to be commercial by 2026 and have the team built up around to do that. Arden's strategy is really to win in the small markets today so that we get the right to address the large markets by 2030, really looking at concentrations like steel, cement, agriculture, blue hydrogen by 2026. We are a TRL6 company, so we have 3 commissioned pilots in the field today in steel, kiln processes, and petrochemical applications, as well as a 1 to 4 ton per day pilot that's currently in design that will be in 2025. This is a large problem, and we know we can't tackle this alone. So Arden provides membrane and the carbon capture membrane process, and we partner with EPCs, fabricators, compression, utilization, and storage companies to provide a complete solution to our customers. So we'd love to get involved. We are starting a Series B this year, so if you're an investor, come talk to us about it. For customers, we're currently evaluating the next pilot and demonstration scales for this, and we'd love to talk about your decarbonization journey. And if you're a partner, we'd like to talk to you about how we can collaborate and make this a near-term reality. Thank you.
Awesome. Thank you, Christine. Next up from Einsted, we have Attilio Grimani.
Hey, how are you? I apologize in advance for any problem with the connection. I'm in China and connectivity has been a little bit of a pickle. So with no further ado, hi guys and girls, I'm Attilio Grimani from Argentina. I'm CEO and co-founder of Einsted, where we are developing technology for last mile or on-site hydrogen generation and carbon nanotubes. Well, the problem that we are facing is, of course, the eliminating carbon emissions in record time, especially in industry. And of course, everyone is rooting for hydrogen to be a big player in that task, but hydrogen has problems of its own. Mainly storage and transportation has been very hard to solve because of hydrogen volatility, and it is taking roughly half of its cost to produce. So if you can change to the next one, please, Petra. Thank you. So what we are doing we have been working on at Einsted is a solution that allows us to produce hydrogen on site and obtain a blend of methane and hydrogen, and also carbon nanotubes using the networks of methane that are already in place and are being used right now. This gives us scalability and flexibility, and of course to our clients. And the trick to doing this is that we are doing this with our patented technology of ultra-fast plasma pulses and without heat. This allows us to have a very competitive price of hydrogen with a very efficient use of energy. And as a plus, we can say that we use 0% of water in the process. Also for carbon products, we are estimating 25% savings compared with a needle coke. And once again, no CO2 emissions compared with other technologies. And when we say that we don't use any heat, this is just for context. We really don't use any heat. We are at room temperature right now, which allows us to be very efficient on the energy consumption, but also in the materials of choose for our equipments. That allows us to be economical and very flexible for our clients. And what clients are those? Well, we are targeting at right now 2 main lines of revenue: decarbonization as a service and highly conductive carbon. Decarbonization as a service for steel, cement, and oil and gas as first case uses, and conductive carbon for building materials, batteries, cables, and the automotive industries. On the long run, we are planning to increase the amount of hydrogen obtained from the process and eventually reach a pure hydrogen, turquoise hydrogen market, which is prospected to be really huge by 2030. And as for the first vertical of the decarbonization service, we are looking at a $30 per ton of CO2 avoided in the processes, which allows us to project revenue of about $2 million by that's end of 2025. As impact goes, the flexibility that we have allows us to be very scalable. I'm going to rush here. Next, please. We have 2 pilots experience going on for the end of this year with Asinda and Vista, which is also our investor. We have a team of 18 people working, scientists and non-scientists, engineers and all. And we're looking for $1.2 million, of which 50% is already invested by Vista and our previous investor. That's it. Thank you so much for having us. And any question, feel free to reach out.
Thank you, Atilio. And luckily, the connection was perfect, so no worries there at all. Next up, from Electrified Thermal Solutions, we've got Daniel Stack. Daniel, the floor is yours.
Great to be here. Thanks for the opportunity. So we founded Electrified Thermal Solutions to decarbonize industry with electrified heat. And the main market pain point on its face, which I think a lot of folks in the room can appreciate, is that if you're an industrial who's burning fossil fuels for heat, there's really no affordable zero carbon heat option for you to switch to if you want to stop doing that. And there are kind of 3 main features that we see. First is the good news that we have zero carbon electricity becoming cheap, becoming available. There's 2 challenges with it. First is that firming it is expensive. That is making it there when you need it. If you're storing it in a battery, it's incredibly expensive. It'll at least 10x your energy cost. Second problem is that industries, of course, need heat, not electricity. So if you could store it in a battery, it needs to come out as high temperature heat at the end of the day, often flame temperatures. So how do we take the zero carbon electricity, make it firm, and make it very hot? And so the technology we've been developing is called the Joule High Thermal Battery. It is basically a box that sits on your site. It takes in electricity whenever it makes sense, whenever it's cheap, abundant, available from solar, wind, hydro, nuclear, whatever the grid has on it, or whatever is co-located with you. The electricity comes into the box. It turns into heat at 1,800 Celsius, and we can deliver that heat at anywhere up to that temp as a hot gas that can flow into your furnace, into your boiler, into your kiln, wherever you're burning fossil fuels today. You can even run it into a power plant to reproduce electricity later. So we can do the job of fossil fuels with this system. A couple of main points. I already mentioned that it's very hot, 1,800 Celsius that we can put out. It is affordable. It is at least 3 times cheaper than any green hydrogen approach. Take that same electricity, you want to split hydrogen, the electrolyzers will cost you a lot, and the efficiency will be worse, so you'll have higher OpEx. You know, electricity to heat directly is near 100%, it's 95 plus. Water splitting is maybe 60, maybe 70% efficient. So you take a loss on the CapEx and the efficiency there. So we have a huge cost advantage over hydrogen. We're going to need hydrogen, but the less we need, the better, especially for heat from a cost perspective. Retrofittable, we can plug into existing processes, give you your heat directly. Wherever we can give you a pipe of hot gas to plug into your furnace, we can do the job of fossil fuels. And so it's very important for many customers that we can plug into. And modular, we can put more boxes on a site or less as needed. And the breakthrough that lets us do all this and do it affordably is roughly 10 years in the making, mostly during my time at MIT, which is where we spun this out of. And that is electrically conductive fire bricks, or e-bricks. And so we developed these bricks because we recognize that electric heaters are the bottleneck if we want to electrify industry. They don't go hot enough, they burn out too fast, they don't do the job to replace fossil fuels. So we developed the electrically conductive fire brick, which is what is filling the box that's on the screen here. It's what builds the Joule High Thermal Battery. And so with that breakthrough, we can be hotter, cheaper, and more scalable than any other electrified heating option and any other thermal battery approach. And it comes down to really what's available today. Anyone else trying to do this, it's a good thing to try and do, but they're limited by what is off-the-shelf electric heating technologies today. You need to be hot, cheap, and scalable. The biggest thing is that our bricks are oxides, which means they do not oxidize. They don't burn out like traditional heaters. That means we can run at flame temps for decades, unlike everything else on this screen. We also can work in air or CO2 or other industrially relevant environments. There's no extra heat exchangers, no extra middlemen. So we cut down on CapEx tremendously. And so we can have this advantage on temp and on cost, and we can do the jobs that nobody else can do. We plan to scale to the largest, hottest industrial needs. We have an elevator-sized box right now running at our site here in Boston, where we're stacking these bricks up. We got our first multi-ton batches made last month. So we can, whether you want 2 tons or 2,000 tons, the supplier can make it for us. So we build that into our system. What comes next with our current fundraise is to build it bigger. Ultimately, we'll be going to hundreds of megawatts, but first we'll be doing this kind of 5 megawatt scale shipping container style system in the next year or so. But with these scales, we can go to hundreds of megawatts. We can also do heating walls inside furnaces. We can also hook up to power plants. So there's kind of a whole suite of things we can do with this tech. All in all, we expect double-digit percentage of global energy flowing through the e-bricks. And so, you know, the main roadmap here, and we are fundraising right now. Please get in touch with me if you haven't already. We are moving pretty fast on this. We're raising $20 million. Last year was all about the pilot. This year is all about our commercial demo, megawatt scale, which the current fundraise helps us do tremendously. But we've also won some government money. There are some grant co-signers on the screen there, 3M Amy's Kitchen, TVA and Boots Unichem, and another large $70 million grant that we won recently to do a chemical plant. And so this fundraise we're doing right now for $20 million, we've got a little over halfway there now, about 2/3 of the way there. And yes, please get in touch if you're interested. We're really engaging industrials across all the different spaces that need heat. And I think it's probably a lot of folks in the call here. So yeah, looking forward to deploying this tech to industrial sites that are, and industrial customers that are willing to work with us on pilots and demos. And please shoot me an email at danielstack@electrifacthermal.com, daniel.stack. Thank you.
Thanks a lot, Daniel. It's really interesting. Next up, we've got Bob Flint from Miraco.
Thank you so much. Okay, so while I'm just bringing up my slides, just a quick comment that it's just amazing to be part of such a vibrant community of innovators like the people you're hearing on this call. So this is a very exciting time to be in energy. So Miraco is an emissions measurement company. We're a startup based in the UK, and we aim to provide the best possible view of what's happening in the real world by digitizing emissions such as methane from oil and gas infrastructure. And we help operators understand where their baseline is and how they're improving and making progress towards their net zero goals. So the problem we're addressing, first off, many of current techniques that are available to operators simply don't provide the level of accuracy and performance that are needed to really interpret the results. So that may expose operators to downside, things like fines or non-compliance risks. But also it means that they can't properly understand the root cause of where these emissions are coming from. And in fact, the key is to steer their investment towards the areas where they get the best bang for the buck. So reducing their emissions using the most efficient use of people and resources. Many of these measurement processes are also pretty clunky. They suck in lots of people, they're distractive and interrupt operations. Well, they just result in data which is simply not available to other systems, so that it's islanded and you can't squeeze the best value out of the information. And then finally, we think there's lost value which is sitting on the table. So if you can get provably to a low carbon position, then you can monetize that through carbon credits and other mechanisms. So maybe even low carbon energy products such as responsibly sourced gas. So our solution is based on a proprietary sensor. We use a laser. We essentially take laser spectroscopy out of the lab and into the field and operate in all weathers. We throw a sensing umbrella across a whole facility using a single sensor. And we use that to measure what's happening in the real world at source and facility levels. And we're working on this with Shell and other customers. So we're building an end-to-end digital system. It's got high spatial fidelity, high temporal fidelity, and a great deal of sensitivity. So we produce an update on what's happening every couple of minutes. And we feed that into digital systems. So we see the opportunity here eventually not just to provide information on what has happened, but to predict what might happen in future and to manage and optimize and even reduce emissions in the digital space. Example projects of around 20 that we've conducted. So this was on an operational site in the Netherlands, pretty poor weather conditions, and we were able to monitor all of this facility from a single sensor and detect down to parts per billion sensitivity, and even detect leaks at around 1 kilogram per hour that no other technique had spotted. So we believe that there is great value in having differentiated hardware. You can't backfill using AI or ML if the data is not good enough. And we know that surveys, for example, many of the fallback techniques like flyovers or drones don't capture the intermittent emissions that represent about 50% of methane escapes. IoT systems are pretty low quality in terms of their sensitivity and also cause a lot of false alarms. They're essentially burglar alarms for methane. Camera systems often have restricted range and need pure line of sight to where the leak is happening. So if you want to measure effectively and accurately, you really need an optical system using a laser. And we found a way of taking that out of the lab and putting it into realistic conditions, even in poor weather. We're addressing a market opportunity which Bloomberg and others see as about 15 billion in terms of scope. And we're looking at facilities where there is a considerable complexity, so tens or even hundreds of leak points. That's our sweet spot. We've reached a point in our development where we've validated the technology with Shell, and we've published our results. We're generating revenues, and we are able to start scaling. So we've just raised a C+ round of $2 million, and we're looking to a Series A over the next 12, 15 months to drive commercial uptake and improve our product roadmap. We'd welcome any approaches in that regard. Thank you so much.
Thank you, Bob. That was great. Next up, we have from Thea Energy, Brian Berzin.
Great. Well, thanks so much for having me. I'm Brian Berzin, co-founder and CEO of Thea Energy. Thea Energy is working to commercialize a scalable form of fusion. Fusion is the process that powers our sun and all stars. Fusion is responsible for all energy and elements as we know it. Via fusion, the sun creates the wind that spins turbines, the light that drives solar panels, photosynthesis, and just about everything in between. Fusion is a clean and safe power source where the fuel is hydrogen, the most abundant element in the universe. Fusion can uniquely provide a limitless source of zero emission baseload energy, allowing us to mitigate climate change, alleviate the geopolitics of energy, and create cheap power for the future of humanity. A quick overview of our company. In 2022, we spun Thea Energy out of Princeton University and Princeton Plasma Physics Lab, a legendary US Department of Energy national lab focused on fusion research. We closed a $20 million Series A in 2023, and that's allowed us to build out our company and scale our tech. In 2023, we were also selected as one of the 8 milestone companies in the DOE's inaugural Fusion Development Program, which we formally signed just this past week at an event at the White House. Our type of fusion system is called the Stellarator. The Stellarator was actually invented at Princeton Plasma Physics Lab, and because of the work at the lab and other leading research institutions, we now have a bedrock scientific foundation for the system. To create fusion here on Earth, we have to build devices out of hardware that can create conditions simply the center of the sun. That's really hard to do. The Stellarator uses large magnets to constrain a plasma, the fusion fuel, in a very specific way to do this. While the Stellarator system configuration always had some inherent benefits that allow it to be an ideal power plant architecture, the engineering and manufacturing of these physical magnets and system hardware, it's been the Achilles heel of the system, and it's really limited the scalability of it, as shown with prior Stellarators of the world on the left-hand side of the screen. Our company has been focusing on how to solve this challenge by eliminating the complicated modular magnets and replacing them with arrays of planar or flat programmable magnets that can be dynamically controlled via a software stack, as shown on the right. Our architecture provides some practical benefits for real-world power plant operation. Every magnet is controlled individually. This means that we can have a dynamic feedback loop, and we can change parameters on the fly. We can fine-tune out hardware wear and tear, or if one magnet is mounted a millimeter off axis, it's now just a control system change. For prior stellarators with modular coils, that would have been catastrophic hardware defects and caused the system not to work. And because all these coils are flat, we also have a maintenance scheme where you can remove entire sections of the device and have access to components for routine maintenance or replacement over the lifetime of a power plant. This year, we're building out our core tech, high temperature superconducting magnet arrays at scale and at high field. We have a programmatic advantage here that's pretty unique. Because the components of our magnet system are smaller, simpler pieces of hardware, we've been able to iterate our technology very quickly. From 1 month to the next, we can iterate an entire generation of magnet technology. This means that we're able to advance very rapidly and much more cost effectively than just about any other form of fusion energy, where systems normally are extremely large, extremely expensive, and oftentimes take a year or multiple years for a single piece of hardware. So right now we're iterating on these building block magnet coils. At the end of 2024, we'll take these components, operate them in a 3x3 array of 9 magnets, a system that will allow us to show at scale that we can make those complicated and very precise magnetic fields required for a stellarator, but using simpler, scalable, controllable hardware. This will be a big moment for us in the entire industry to show that there's a way to build a mass manufacturable and scalable fusion system. The step after this is when we will raise a Series B round to build a large-scale, fully integrated stellarator called EOS. That system will be online around the end of the decade. This system will show our technology at scale and create fusion conditions that are relevant for a power plant. Following the construction and operation of EOS, we'll then be in a position to deploy fusion power plants across the world at scale with end users. Thanks so much for a couple minutes of your time today. Please visit Taha.energy if you'd like to learn more about our tech or stay in the loop on our progress or talk about our upcoming Series B. Thanks.
Thank you very much, Brian. That was super interesting. And last, but certainly not least, we've got Thomas Fudge from Waze.
So my name is Tom, co-founder and CEO of Waze, and we are unlocking the power of waste to make it the fuel of the future. So I want to introduce you to Andy. He owns a brewery and he wants to become a really sustainable brewery, but he has a lot of challenges. He generates huge volumes of waste on site in both solid and liquid forms. He also has a real difficulty decarbonizing his thermal energy demand. And this is really common across multiple industries like the food and beverage, but also harder to treat industries like the paper manufacturing industries as well, where they have really high thermal energy demands. He currently doesn't have a grid connection, so he has to use oil boilers, but also lots of the companies are really struggling to try and decarbonize this energy by having to use natural gas. So to overcome these challenges, Andy looked at implementing on-site waste to energy solutions like anaerobic digestion. But anaerobic digestion is big, it has slow processing times, and it's inefficient at breaking down all of the organics and turning those into methane and biogas. And this is where we're helping Andy, because we've developed a new process, which is a small modular solution to treat all of his waste on site. We can break down those organics to generate sustainable energy that he can then use to decarbonize his thermal energy demands. He can then treat the waste so it can be safely discharged back into the environment. So he removes the need for transportation, and ultimately the whole full circular process is extremely carbon saving. Now, anaerobic digestion, which is the main technology to convert organics into biogas, is a tank where you have bacteria, and these bacteria break down the organics within the process. They have 4 stages, and these 4 stages have competing reactions going on at the same time. And this is why you have quite a slow breakdown of those organics, requiring these bacteria to slowly take complex organics and turn them into biogas. And in the biogas, you generate a lot of carbon dioxide. So to 40 to 50% of the gas has no energy. And we've developed a process called electromethanogenesis. And this is the future of anaerobic digestion. And this is where we have these electrodes within the reactor, which can accelerate the breakdown of organics. We can then unlock sort of different types of waste streams and make it economically viable. And we also generate a better quality biogas, where we generate increased methane concentrations, so it's easier to upgrade into bioenergy, integrate into the grid, or increases the efficiencies of when it is used in boilers or combined in heat and power systems at industrial sites. Now, the way the technology works is on these electrodes, we grow electroactive bacteria. And these bacteria are really unique because as they break down the organic compounds within the waste, they generate and release electrons from themselves onto the electrode surface. Now, we supply a small potential to these electrodes, and it's the same amount as having some light bulbs turned on, so it's extremely energy efficient. And this directs the flow of those electrons through the circuit. So we can then start evolving hydrogen within the reactor. And this means that we can then start converting that carbon dioxide fraction of the biogas into methane. So we can increase the amount of energy that you can generate. Now, compared to anaerobic digestion, we can treat the waste 3 to 10 times faster. So it's a 70% smaller site than the existing solutions. We increase the energy output by 30%, maximizing the amount you can get from your yields. We also increase the amount of organics breakdown and removal, making it easier to concentrate sludge or ensuring you can discharge to land. We can operate at lower temperatures, making it more economically viable to unlock energy from different waste streams. And we have an intelligent biosensing operation, which is really game-changing and mean that you do not need skilled engineers on site. The way the biosensing works is because we're generating an electrical current that is biologically produced. This is the same as having a health monitor throughout the whole reactor. We then are using an AI control system to automate the whole process. So we can then start really maximizing the efficiency of every single asset. And we can then monitor making sure we're getting the full amount of treatment at the end of the process. We're integrating that into modular designs, which we're now installing for various different customers, from dairy farmers, breweries, and distilleries. And we're scaling that technology up so we can integrate into large-scale centralized anaerobic digestion systems. So we can maximize biomethane generation and really increase the impact that this gas can have. And together, we can protect our most precious resources. We're looking to really scale up our work, working with large industries, partners, and really open to have new connections with industry. Thank you very much.
Thanks so much, Tom, for that. And to all you entrepreneurs who just spoke, and a reminder for the audience, if you want to talk further with anyone who just spoke, you can, of course, either reach out to them directly or via their websites, or if you reach out to us at GCV or the Global Energy Council, we'll be more than happy to connect you with anyone who just spoken. Now, I know that the most interesting part is over, but if you'll just bear with me just for a couple more minutes, just to let you know of some of the other interesting things we have coming up at GCV. So next week on June the 12th, so that'll be next week, Wednesday, we have the next edition of the Next Wave webinar series, this one on sports tech. So moving the goalposts, how to invest in the changing world of sports. It's going to be a super interesting one. We have a really interesting panel lined up for that one. So please do tune in if you are interested in the world of sports. And then later this month, on the 24th to 26th, we have the GCV Symposium in London. In October, we got the GCV Executive Leadership Forum in Menlo Park, California. The same month, if you are from Latin America or interested in investing in Latin America, the Corporate Venture in Brazil event on October 28th is a must do. It's really fun one, always interesting, highly recommend it. And then of course the biggest event of the year next March, the GCVI Summit in Monterey, California. You can contact us anytime and check out the rest of our coverage at globalventuring.com. And that is about it from us. Thank you all for tuning in, and good luck to all you entrepreneurs. Wishing you all the best. Thanks very much.